Now you see this is going extremely fast, or we have already counted more than 100 crops. Hi, welcome to this new video. We're now going to see how to count any object using AI vision. This is something that many of you are interested in, and you also left a comment in the previous YouTube video where you were asking about object counting based on a line and also counting people who came to an event. So I saw interest, so please leave me a comment always with your feedback because I will read them and based on them I will make the next content. And here we are. Now, how to count any object. In this video we're going to see how to build an object counting from scratch. So we will see coding from scratch the logic of object counting. And also we will see two different types of counting. So if you're not familiar about counting, you should know what are these two types. One is the detection-based counting, which is the most basic one, and it's what you usually see in video tutorials, and it's the counting when everything is visible on the frame that doesn't take into account the time and the movement of the elements that get out of the frame. And then the most useful, most complex one is how to count objects by tracking them, so tracking base. And this means having a line when the objects cross this line, we count them so that we can count infinite objects over time. We have a few video examples that we are going to use. This is one example that we will use in this video where we're going to detect and count vehicles. We will count the vehicles that are crossing a certain line. Also, we'll count detection-based vehicles that are waiting, so vehicles that are always on the frame and visible. Then we will count the people. We will see how to deal with small elements and how to get the best accuracy in such cases. Then we'll see tracking and counting of very fast moving objects. In this example, we have a drone flying over a broccoli plantation, and we're going to have a very reliable counting despite like the high speed of this drone. And you can use the same approach also when you have a stable camera and there are very fast crossing objects like this. And then we will also look another scenario where we'll have a very big view with very small objects. Like in this case, we have a drone and on the ground we have a lot of sheep. We want to count them. So we will see what's the best approach to also count very small objects. This is great when you have like satellite images or drone views, or even if it's not, or CCTV cameras that are very far, like for example, in the top of a building that take a very high view. And then after this, of course, in the middle of the video, we're going to also talk about the most common problems that you can get with the counting and also the mistakes that you should avoid and the best practices. If you're ready now, let's go and start coding and see the logic step by step. Let's now start building a code from this specific video right here. We will do first a base detection counting where we count the cars that are visible and we count the people that are visible. Here on PyCharm, I'm going to write the code. So first of all, we need to load the video and I'm going to build everything from scratch. I will be very fast on this, just giving you the logic. If you want to know more, I have a lot of other sources where you can learn this from scratch and understand everything on the basic side. So let's import CV2, which is the OpenCV library. Now let's load the video, load video. So we need a capture object, CV2, the video capture. Here we have different videos. So I want to load the traffic 1.mkv. Now let's display the video. So we need to put everything into a while loop. So here the copilot is giving already some suggestion and we're going to take them. So we load the video into a loop. From the video we extract frame by frame and then we see to him show everything on the frame. Let's now run this one. And here we have the video. So we're running this video with Python. Now, what is the second step? We need to perform object detection. So object detection, engine.object detection. We're going to import object detection. Now, to detect objects, we need a model. So we load the model, load object detection model, OD object detection. And now we're going to use the YOLO 11. Doesn't matter which model you use, 8, 12, the new models, like the structure is always the same for the detection. With new model, you might get better accuracy, but the following is the same. So don't worry if you see a different version than what's available when you're watching this video. Right here, now, let's perform the detection. So we need to detect all the objects that are in the frame. So detect objects. So we get bounding boxes, class IDs, scores, equals od.detect. What do we want to detect? We want to detect on the frame, and then we can leave this as default image size 640. So this is the image, how much it will be shrinked from the original size to perform the detection and the confidence score. Now, to make sure that we're doing the detection correctly, let's display everything. Display detected objects. So we loop through everything. We loop for bounding box, class ID, score, in, zip. So we're going to loop through all of them at the same time. Now let's just display the bounding box. The bounding box is the position of each rectangle of the objects detected. So let's run this one. Now we see without distinction bounding box on everything that this model can detect. We have the bounding box around the cars, we have bounding box around the people. Not always, because it means that not always is able to detect the people. So that's some problem that we will need to solve later. Now, if we want to detect only the cars, the vehicles, we can do that. We can do a simple thing. We want to filter the detection to only detect cars. How to do that? Before we move further, please note that all the sources that I'm using in this video are available inside the AI Vision Academy, where you can get also in-depth lessons from scratch on how to build AI Vision projects, and also you can get community access if you need help with your own project, and also Q&A monthly calls. If you're serious about computer vision, I can't wait to see you there. We're now using the YOLO 11 standard model. There is a model that can detect 80 different classes. What classes can we detect? Let's see them. Simply now I'm going to print od.classes. Here we have a list of the classes that we can detect. 0 person, 1 bicycle, 2 car, 3 motorcycle, and so on. So we have an index 0 with the name of the classes. And we can use this right here to filter. So classes equals, and I can put the index of each class that I want to display. In this case, we want to detect the vehicles, and among the vehicles, we have like different categories. We have the car, which is class 2. So we put class 2 for the car. We have motorcycle, which is a vehicle. We have the bus, we have truck. So that's what we can detect from this model, and we can run this. And there is also a better way to track and count vehicles. We can talk about this in another video. You should create your own class for all the vehicles. Now, I don't want to get into this because this will be very specific. I'm just giving you an idea about the counting now. So 2, 3, 5, 7. Let's run and make sure that we are tracking the correct vehicles. So let's see if everything is working correctly. We should see only the bounding box around the vehicles and not around any other object. So far, everything is working well. Let's now perform the most simple type of counting that we can perform, and it's the detection-based counting on everything that's visible. Let's do that. Right here, we are displaying, here we get the bounding boxes, the class ID, and the score. So this is what we're showing. On the loop, we show the vehicles because we're filtering the vehicles. This means that the number of the bounding box will be just the number of the vehicles that we have. So if we want to display count of detected objects, the count is the length of the bounding boxes, as simple as that. So we can display this in real time in the screen, cv2.put text, count, and everything will be displayed in the top left of the screen. So let's learn now this one. Now in the top left of the screen, you see count 10, 12, 11. This is the number of yellow bounding boxes that are displaying right here in real time. So the maximum element that we are able to detect here in real time with this. When is this useful? In this case, with the there are many use of such tool for counting. One could be the queue base, the length of the queue of the cars or the vehicles in general in a certain time, so you can understand like the traffic. So there is something that's required, but it needs to be slightly more advanced. So we will see also how to do this. The detection count base can have also a region of interest if we want that to be more defined. Let's, for example, draw a polygon in these areas so that we have the maximum count of this queue right here in real time. Now I need to understand how to get the location of a specific point. For this, we can create another Python script to help with that, to speed up our process. I want something that when I click on a point in the video, it gives me the coordinates so that I know where to draw the polygon. Draw polygon on click. And this basic operation is something that the Copilot can do, so there is no need that we draw that, build that, create an OpenCV script that loads a video and prints the coordinates on mouse click. I have now my code and let's test it. Okay, the video is running. So ideally when I click the mouse, I should print the coordinates. Let me find the 4 coordinates where I want to draw the polygon. 1, 2, maybe more coordinates. 3, 4, 5. The copilots on this stuff works extremely well. So mouse click add. So we have these 5. We have these 5 coordinates. We use them to draw the polygon. We draw this polygon and we count everything that's inside this polygon. We can call this like counting area pl polygon mp.array. So here we create an NumPy array with the coordinates that we got, so 893, 578. Here we have the 5 points. Now, before making any counting, let's make sure that this polygon is correct. So to make sure of that, we can just draw it, polygon, and cv2.polylines, counting area polygon. Here we have a polygon as we wanted. What can we do now? We want to check only the vehicles that are inside the polygon. If they are inside this polygon, then we make the count, otherwise we don't. How to do that? We use some very basic OpenCV function which checks points inside the polygon. To do that properly, we need to check on every single box, on every single vehicle where it's located. Here we get the bounding box of all the vehicles. Here we loop and draw them one by one. While we're drawing them, we can check is the vehicle inside the polygon or is outside the polygon. Check if the detected object is inside the counting area. Great. So right here, how do we do that? We take the center X of the object, center X and center Y, of course. And then we have this function, which is cv2.pointPolygonTest. It will check if it's inside or not. If it's inside, we want to count this. So if inside is greater than 0, so let's do this. Inside vehicle count, inside vehicles is, we start from 0. So each time we find a vehicle inside, we increase the count. Very simple. So if vehicle, let's say if object is inside the counting area, increase count. As simple as that. So if inside is greater than 0, inside vehicles plus or equal 1, and also, and that's it. Let's not do anything else. Here we can draw also a circle. Let's now comment this. Let's just run this. We're running, but I forgot to display it. So let's add the count right here where there is the polygon on the first point. Instead of displaying like the count of everything, let me put a comment into this. Display counting only inside area. So c2.put text, the count of inside vehicles. And let's put this where on this point, on the first point of our polygon right here, so that we have the number right there. And now you see, now I'm pausing this, we have the exact counting 1, 2, 3, 4, 5, 6 vehicles that are inside this area. We have some mistakes sometimes because some of them are not visible, like this last one is not visible. That's another topic to improve the detection. Of course, we can improve it a bit by lowering the confidence. Instead of 0.30, we can say 0.20. And probably this will already solve the problem. So you see now the last vehicle is detected properly. So now 4 vehicles. And so on. If there is problem with the detection outside of this area, it doesn't matter. So the counting will be precise as long as everything that's inside this area is detected correctly. So when you play with values, threshold, with the detection, if your focus is only this area, just focus on that and don't worry if outside of the area that's your interest you get some not proper detection. That's fine. And this one was a detection based count, so counting objects inside the frame, and also here we added like an extra region of interest to count them inside an area. Now let's go to what is most interesting for us, the tracking based count. We will do this now on another video, and then we also can play around with this video. Let's go. We'll now focus on this one where we have a broccoli plantation, a drone view. We want to count the broccoli plants while the drone is moving. So the drone starts slowly, then it will move very fast. So this is a very interesting project which will give you the idea on how many things you can do either with a moving camera for counting or a stable camera and moving objects. It's the same concept. We'll run now the object detection code that we have built before on this scenario. So we will see the plantation detected. Let's now see. So this is now the current result. We have yellow bounding boxes that are detecting the broccoli plant. For this, I created a custom model. If you want to create the custom model for your own object to detect and track and count any object, everything is inside the AI Vision Academy, where you have detailed lessons step by step on how to create your object detector to track anything. Now, a concept that we need to introduce is object tracking. I will be very quick because I have a few videos about object tracking, so you can see that on YouTube, PySource on YouTube, if you want to know more, but let's quickly introduce the concept so that you can understand. We run this, now we'll freeze frame by frame. Now here we have just bounding boxes on the first frame. A video is nothing more than a frame after frame. When we go to the next frame, we see that since the drone is moving forward, the plants are going backwards, so the bounding box is moving backward. Without the object tracking, we just see new bounding boxes. We don't have the association of what was before and what's now, so we need to track them. By tracking, we'll get a univocal ID on each of them, so let's do that. In addition to detection, we load the object tracking, so from engine we import object tracking. Right here after detection and capture, let's load load tracker, multi-object tracker, MOT, so the tracker would be equals mot.ossisort, and now let's track all the objects. Here we pass everything detected inside the tracker, and then let's display everything with the ID. You can see now that each object has a univocal ID, so we have 1, 2, 10, 9, 6, 7. Each time we go to the next frame, you see that the ID stays the same. Even when the objects are moving, we see this is ID 21, this is ID 17, 24 it stays 24, 22 it stays 22, 28 and so on. So it's like giving a name to each plant so that we know what plant is that and we don't count the plus twice. How can we perform now the counting? The most simple approach is to draw a line. So we're going to draw a line in the middle of the screen right here, and then we perform the counting. The most simple approach right here will be defining a region of interest where when the objects are crossing that region, we perform the counting. An idea will be to draw them right here in the middle, something like this. So could be like this, doesn't really matter. We can talk about the sizing and the position later, but the concept is we count only the IDs that are inside. Let's now draw the region and we will see on the code side how this will work. Similar to what we did before, we're going to define a counting area right here, crossing area 1. So we just copy this. I've got already the coordinates. I explained how to do this with the clicking of the mouse and the other file that you can generate, so I will not get into that. Now let's display this crossing area right here. So c2.polylines and the crossing area, and let's now run everything to make sure that we have the crossing area correctly displayed and in the position that we want. This is our crossing area where now we have just the ID 10 inside. What can we do right here? We can do a very simple approach as we did before. We do the point polygon test. So is the polygon inside the specific area? And we have also something in addition. We'll see how to use the ID that we have in addition. If we go right here on the code, here we have the code where we are tracking the drone crops. Right here we are displaying and getting the ID of the drone crops. Let's now do the point polygon test. So we check if the object is inside the crossing area. Is inside. So we have the crossing area, and then we have the center X and the center Y of each plant detected. So if the object is inside, what should we do now? Since now we want to track them over time, we can't just say +1 if it's inside. We need to have some history of what was there. Since we have the IDs, we outside, so before the loop right here, we need to store crops equals and then a set. Right here, each time we detect a new crop, we put the ID of the crop. So if it's inside, if inside is greater than 0, so if it returns greater than 0, it means that it's inside. We want to crops.add, and we want to add the object ID. So right here from the tracker, we have the object ID, we add object ID, and that's it pretty much. Like we have already, that's pretty much the job, if I have to be honest. Now we just need to display it. So let's now display everything. So we want to display in real time the counting. Display count of the detected objects. So we get the length of the crops and then we put the text with the count. Let me also print the crops so that we know exactly why we're doing that. Now on the top screen, it's not very clearly visible, but we see count is 1. Why? Now we have ID 10 inside, and here we see the number 10 inside the crossing area. The 2 and the 1, they are not inside because we are taking just the center point. So center point, as you see, the yellow center point is outside. How do we perform the count? It's simple. Right here, each time we detect a crop, we're going to add the ID inside crop. So we have ID 10, and that's why we have 1. Each time a new ID enters this area, it's added to this array called crops, and so the number increases. So now we have always just the ID 10. Now ID 2 enter inside. So we see count 2, 10 and 2, they are the IDs. Now also ID 1 enter inside, and we have 1, 10 and 2. And you see, despite now they are gone, we have the count because we are adding over time. So you see the difference. Detection is only when they are visible in the area. Now, since we have the ID, so the ID is essential to perform this counting, it can happen over time. And this can be very fast. Now you see, this is going extremely fast. We have 50, 60, so we have the counting, or we have already counted more than 100 crops. And you can imagine how useful is such application in the real world scenario, especially when you have thousands and thousands of objects to count, when you need very fast speed, when you need this in real time. That's where you can apply object counting. Let's quickly see some of the problems and most common mistakes to avoid. Now, what are the most common problems? Of course, there are 2 common problems. Like one, you have double counting. So when the objects enters again in the scene, it can be counted multiple times. Or if it's not entering again, but you miss the tracking or the detection and it displays again, then it counted again multiple times. Or the opposite, miscount. So when the object, for any reason, doesn't trigger the counting, either is not detected or it's not tracked properly inside the region, and so on. And this will get to the 3 most common problems and mistakes that you can avoid. Now I will quickly mention them, and then we can see some samples on some videos to test on how things work. So the first one, this is the most common, is the poor detection and poor tracking quality. If you don't detect the objects properly, you can't, of course, count them properly. The detection is the first thing that needs to be precise. You need to build your custom object detector to train your model with the right data in order to have like the best accuracy possible. After that, you need to implement object tracking. The algorithm must be properly tuned for your own scenario. You must choose the right algorithm so that you have the best tracking possible. Otherwise, you don't get a good accuracy on that. If you have decent, good detection tracking, also you need to define correctly the region quality, and the region must not be too big or a random region in the entire scene, but you need to choose the best place and the best size where to place the region based on the layout that you have, and also the flow that you want to track and count. And also another problem is not using the right camera. If you're using a camera that has a very low frame rate and it's not consistent frame rate, then this is going to impact a lot the accuracy. And this is something that I see quite a lot, not using the right camera, or even using the right camera but not having a good placement of the camera where will make the counting the most efficient. Let's now see some of these things. And if you have questions about this, because we're just exploring the surface of this, please ask below in the description and we can discuss about it. I can bring new content about. Let's now focus on this one. Let's say that you want to count people that are crossing this area right here. So where we have here 1, 2, 3 people. If we draw here a line, we want to detect and count them. What's the problem here? We have two problems. One is the detection. It's terrible here. Like we have most of the time there is no detection of people. And because of this, we don't have a good tracking. And this will make the tracking of this extra super unreliable. There are two options here. If you have a very big view and you want to detect such small elements, you can do that introducing the Sahi algorithm. Let me show you an example of how this will work. Here is an example of the algorithm detecting the ships. You can see that we have almost 100% of the ship detected, despite that they are extra small, and we can count them just like this. So we have a very high accuracy already from the very big view. This is possible to achieve. It's more complex. It's very intense in the resources that you need to use. In our case, this algorithm will not be necessary because we need to focus only on a small area. So what we can do is we can crop the region. We can, for example, take this region right here from the video and just do the detection on this and discard all the rest. So we crop this area even before we perform the detection so that we don't do a detection on a very large frame. Instead, we do a focus detection on a small area, which will give us much better result. It will increase the accuracy with a very high degree. So let's do that. Right here, after we get our frame, we crop our frame. Frame equals frame. And then I got the position of where I want to cut the frame. So we cut it from 583 on the height to 834. And on the width from A637 to A93. This is now our result. I wouldn't say that this is perfectly accurate in general, but it's much better than the one we had before. There are ways either with a higher resolution camera or with a specific train model on this scenario will perform much better. Right here, where you have to put a line where the people are crossing, and there you can perform the counting. So that's a way to try to improve the detection. Also make sure that you draw the area, when you draw the polygon area where you want to perform the counting, where it's the most visible. So if you want to detect people crossing this area from this camera, it's not the best idea to put the polygon here, but you need to put it in the best visible area. So somewhere here will be the polygon. I hope that this was useful and you got a lot of valuable information. Let me know what you think and what you want to see next below in the description. I can't wait to see you in the next video. Bye.